So ultimately, this is the equation, and now you can see that this small r square minus r square is in a bracket. So we will open that. So we will get kq upon 4r r square root of, okay, r square plus r square minus 2r r cos theta, okay, minus, I can open the bracket and I can change the signs at, okay, so I will change the sign, so it will become plus r square minus r square upon the same thing, root of r square plus r square minus 2r cos theta. Now we have to, okay, we have to, what we have to do is, now we have got the equation, but we have to apply the limits, and the limits is from where to where. If you take the sphere, and I told you that at a certain angle d theta, okay, at a certain angle d theta, I am getting a ring like this. If I make this theta, if I make this theta 0, I will get a ring over here. And if I keep increasing theta, the ring will keep passing through the sphere in this direction till the point that theta becomes equal to 180. So the limits are from 0 to 180. So I will write here 0 to pi. I will write 0 to pi. And now if I solve that, okay, look here, pay close attention. That is, I hope you are able to see, k q upon 4r capital R square. Okay, sorry, uh, the square was on small r. So yeah, one correction. Okay, okay, no problem. And now, if you have to put the value of pi, see, look here, cos pi is what? -1. -1 will convert this into a plus. So ultimately, you'll get small r square plus capital R square plus 2r. Okay, that entire thing can be written as what? Small r plus capital R whole square under this root. Okay, and same thing we can do for that also, r square minus r square upon root of r plus r whole square. Okay, and then we will get minus of, okay, we will get minus of, you put 0 now, what you will get if you put 0? Okay, if you put 0, cos 0 becomes 1, and if cos 0 becomes 1, then you'll get this as r minus r whole square. So I will write that root of r minus capital R whole square. Okay, plus you put 0 away, it's the same thing. So I will just r square minus r square upon root of r minus r whole square. The bracket. Is this visible? Okay. So and so I have just rewritten it back, and now you can see that r small r plus capital R whole square can be the root can be removed, and so I will just remove that root from here. Okay, I will remove the root over here and this square over here, so it will become r plus r. Similarly, I can do it with that this side of the portion. So what will become? I'll just remove the root. This is what will remain, r minus r. Okay, same thing over here. I'll just remove it. I'll get r minus r. I hope this thing is very clear. And now if you see, this capital R square minus R square is in the form of a square minus b square, which I can again write as, I'll just remove this and replace it. So what I will get? I will get capital R plus small r and capital R minus small r. This, and again I'll remove the square root, and square root of this, it will become r plus r. So if you see, this gets cancelled with this, and ultimately you will have an equation. This is small r plus capital R plus capital R minus small r, and again small r gets cancelled. Ultimately, what remains is capital R plus capital R. So I will rewrite the equation, and If you're getting confused, try to do it. Try to solve it yourself. You'll come to this conclusion. 4r square capital R. So it's a very big. So it will become 2r, and I'll keep that as it is. That is r minus r. Okay, plus r square. If I do that for the same thing, I can say r square minus r. I can write it as r plus small r and r minus small r upon small r minus. It's a lot of r's. Basically, I'm telling a lot of r's in my video, but I hope you understand this equation, and this equation is basically the general equation. This is your general equation for electric field intensity. This is your general equation for electric field, okay, intensity at the point P. Based on this, there are two cases. Based on this, there are two cases, and I will discuss that. Okay. So for now, this is the electric field intensity at a point P. Okay. This is a general equation. So as I said, I have just rewritten it down. That is electric field intensity at a point P because of the hollow sphere. Now the first case, let's consider this entire thing. This hollow sphere is there. Okay, and I told you that this point P is at a distance of small r from the center of the hollow sphere, and this entire hollow sphere is having a radius of capital R. But what if I put this condition that small r is basically very smaller than capital R? That means this point P is inside. If this point P, okay, so now what I'm trying to do is I'm telling you that this R is so small that this point P basically comes inside the sphere, somewhere over here. So if I apply that condition, over here, rewrite this equation. We can write it as kq upon 4r square capital R, okay, 2r minus. How can I rewrite this equation? Can you guess? Can you give me a guess? Okay, so there are some things which are very important to understand. If this r is so small, then I can change the signs. That is r minus r, okay, and I can write plus this as it is, r minus r, r plus r upon r minus r. You understood what I've done? And so now this term gets cancelled with this. Once this term gets cancelled with this, you simply get a you will simply get shocked with the answer 2r minus of, you open this bracket, what you'll get, capital R minus small r plus capital R plus r. So ultimately, wait, I'll just rewrite over here only, capital R plus r. So ultimately what you're going to get is this r and this r will add, so it will become 2r. This r and this gets cancelled, so you will get over here in this small bracket, you will get 2r, and finally the answer to this entire integration will be equal to 0 if you put this condition that small r, okay, the distance from the center of the sphere to the point P is so small that the point P basically gets inside the sphere. Okay, so that is the first case. Now, and so the second case is when R is greater than capital R. Small r is greater than capital R, which simply means that point P is very far away from the spheric hollow sphere, or at a certain distance, much greater than the radius of the sphere itself. Okay. In other words, look here, diagrammatically, if I explain, this is going to be capital R, and the distance between the point P and the center of the sphere is going to be smaller. So this distance is much greater than the radius of the sphere. That's what it symbolizes. And in that case, how can we rewrite the equation? It is very simple. It is kq upon 4r square, capital R, 2r minus of. I will just take minus. Let's just keep it here. R minus r. Okay, and I will do one thing. I will just take minus out of this term. If I take minus out of this term, what I will get? R. Okay, I will get small r minus r, small r minus capital R, r plus r. In this case, this term gets cancelled with this term. What ultimately remains is kq 4r square capital R 2r minus r minus r minus r. So here you can see r and r get cancelled. This becomes minus 2r, 2r plus 2r, 4r. So I will write that. This entire becomes 4r. It will become 4r. 4 gets cancelled. R will get cancelled. So you get kq upon. This is the electric field intensity at a point P, which is outside the sphere. So finally, now you know that in a hollow sphere, if you want to find out the electric field intensity at a point P, which is inside the hollow sphere, okay, E for that case will be equal to 0. If you want to find out the electric field at a point P, which is outside the sphere, E will be equal to kq upon r square. So these are the two conditions. This is for inside the sphere, and this is outside. So I hope you understood the complexities of deriving this equations, and ultimately now you understand how Gauss's law makes it so easier to find out these simple equations. So you should know how to derive it using integration method as well as Gauss's law. This is all I wanted to tell you all. So hope you all have understood, and hope you all will keep practicing this. Keep practicing the derivations and keep practicing numericals based on this. Okay, bye bye.